Okay, this is topic 38. I wanted to record this, so even if you saw me do this live, I would like for you to watch this. I feel like I can do a better job now. Okay, so if we have a 6-foot tall man that walks away from a 15-foot tall post at a constant rate at 1 foot per second, how fast is the length of a shadow increasing, and how fast is the far tip of a shadow traveling? All right, so the first thing we should always start with is a picture. All right, so if I draw a picture, I'm really not that good with pictures, but here's a picture here. Okay, and it says that this right here is 15 feet. And we have a 6-foot tall guy that's walking away. He's walking away from the post. Okay, and the length of his shadow, I'm going to do this in pencil. I don't know how well that turns out, but you have a shadow here. You have a shadow. I don't know why his arms are down here and his arms are up, but whatever. Alright, well, you have a shadow right there. Make that guy a little bit taller so he can hit that top. Right, so this represents the beam of light that comes down, and here's his shadow. Okay, so notice that the guy is not going to get any taller during this problem, so this is going to be 6. And notice that now we're going to put variables on the things that are going to change. Alright, the things that are going to change is, I'm going to call this Y. I'm going to call this the length of a shadow is going to change, so therefore I'm going to label that Y. And also what's going to change is this distance right here. The distance between the guy, between the pole and this guy walking away, this distance is going to change, and the length of the shadow are going to change, right? So I'm going to call this X and Y, all right? And I'm going to leave 15 and 6 because those are not going to change. And so now your job is to try to find a formula that relates this, right? So notice that right here you have two triangles. You have a triangle like this, and you have a smaller triangle like that, right? Before we move on, let's try to figure out what we're trying to look for. Okay, so we're trying to find, it says, how fast is the length of a shadow increasing? So I want to know how fast is this distance right here, this shadow, how fast does that increase as this guy is walking away, all right? So I'm trying to find that. So what I'm going to call that is, I'm going to call that dy dt, all right, because I call this y, so I want to know how fast this length is changing, all right? So that's what I'm looking for. I don't know what that is. And what I'm giving, though, in this problem is I am giving the speed at which this x is changing, right? As this guy walks away, as he's going to the right, this x is going to be changing. So therefore, this is going to be dx dt. That's what I'm going to be looking for, all right? Sorry, that's what I'm going to have in this problem. Excuse me. All right, so right here, this is how fast this guy is walking away from this pole. Okay, so notice that this is going to be positive only because the length of x is actually going to be increasing. Okay, now the second part that I'm finding here, all right, is asking me to find how fast is the far tip of the shadow traveling. All right, so to figure that out, I need to figure out how fast both of these are changing. All right, how fast is this length of the shadow changing? And to do that, I'm going to add the speed or the rate at which the guy is walking plus the speed at which the shadow is lengthening. All right, so again, this is the rate at which the tip of the shadow is traveling. Okay. So after that, say that you didn't even know that. Okay. However, there's a formula when you have two triangles and they're similar triangles. You can set up a proportion or a ratio, right? So anytime you have two triangles like this, you can set up a proportion. So anytime you have a similar triangle, you're going to try to set up a ratio. So notice that this one right here, I can have, let's say that 15 and 6 are related. Right, notice that this right here is one triangle. This is 6 and this is y, so the bottom is going to be y. And on 15, this bigger triangle, the base of that triangle is going to be x plus y. Okay? And you can set up a different proportion. If you wanted to set it up like this, it wouldn't really matter. If you wanted to say, I don't know, like 6 over 15 is equal to y over x plus y. So either or would work on this scenario. Okay, so notice that when you cross multiply here, you would get the same thing. So when I cross multiply here, okay, you would have 15y is equal to 6x plus 6y, and notice that if you cross multiply here, I get the same thing, right? So it doesn't matter how you do it. All right, at that point, if I'm just solving for if I'm just trying to get all the variables on one side, this would be 9y is equal to 6x. Okay. And then at that point, once you're here, okay, once you have set up a proportion, and you can keep solving this if you want to, because at this point you're not really either looking for x or y at that point. You don't know either one of those. What you do is you're going to take a derivative right here. You could have taken a derivative right here too if you wanted to, right? But I'm going to take a derivative here, and that's going to be 9. Let me write it like this so maybe it's a little more clear. I'm going to take a derivative with respect to time. Alright, so I'm going to write it like this, which I haven't written like that, but I want to make sure that you understand that I'm taking a derivative with respect to time. And therefore, because I am taking a derivative with respect to time, this is going to be dy dt. Remember, this works sort of like a chain rule. Actually, not sort of. It works like a chain rule. Alright, and if I take the derivative with respect to time of x, that's going to, or 6x, that's going to give me 6 dx dt. Okay, now as you're looking at this, remember what you're solving for. You're solving for dy dt. Alright, and in this problem right here, I actually already have dx dt, which is 1 foot per second. So what I can do at this point, you can keep solving if you want to. You can maybe divide by 9 here, and you have dx dt still over here. You already have this variable. You already know what it is, so you can actually plug that in. Alright, so dy dt is equal to 6 over 9 times 1, and 6 over 9 obviously reduces to 2 over 3, I'm sorry. So this would be 2/3 feet per second. Alright, so make sure you write me the units for this. Remember that this right here is the speed at which this is how fast the length of the shadow is increasing. Alright, so this right here is going to be part of what you're looking for. Now finally at the end, this should be the easy part. How do you figure out the rate at which the tip of the shadow is traveling? Alright, so the hard part was done over here. We know that if we add dx dt plus dy dt, then I'm going to get the answer. And I already know dy dt, so all I have to do is rewrite that. Alright, so to figure out the second part of that problem, I'm going to add those two. Already know dx dt is 1, and dy dt, the speed at which the length is increasing, is 2/3, because I just found it over here. So this is going to be 1 2/3 feet per second. Okay. Okay, so that's that. Okay, so if I go to the back now, and on example 2, alright, I would like to do this one a little better than I did for most of your classes. Okay, so notice that right here you have a dock, a winch is reeling in a rope at a rate of 2 feet per second. The winch is 20 feet above the surface of the water, and the rope is attached to the boat. Alright, so the first thing we have to do is draw ourselves a picture. Okay. So this is some kind of winch over here, and there's a boat. Okay, so there's a boat that's being reeled in. So notice, as you read this problem, it says that the winch is 20 feet above the surface of the water and the rope is attached to the boat, to a boat. This attachment is at the water surface. How fast is the boat moving when 22 feet of rope is paid out? Okay, so right now what I have, what's not going to change is this number, all right? The winch is always going to be at 20, so I'm going to have to write a constant. Now, notice that the rope is going to change over time, all right? So therefore, I'm going to have to write this as R, okay? And this distance right here between the boat and the dock is going, I'm going to name this X. You can call it anything you like. Okay, and I notice that you have other information, right? But if I'm gonna try to solve for anything like this, what I can do, the formula that relates these things together is the Pythagorean theorem. All right, so I will have 20 squared plus x squared is equal to r squared. Right, remember the mistake that a lot of kids made is that they try to plug in the 22 right away. Don't do that, okay? Notice that r is going to change and x is going to change. All right, so you're going to have to take a derivative of this. But before we do that, and this is really up to you, sometimes I like to do this first, take the derivative and figure out what is it that I have and what is it that I need. However, on this one, since we're already talking about it, right, we need to, what do we need to find? That's the main question, all right? It says, how fast is the boat moving when 22 feet of rope is paid out? Now this right here is that distance, right? That distance is going to be decreasing, right? So this right here is going to change over time. That distance x is going to change over time, and that's how fast the boat is moving, all right? Now what I do know is that the winch is reeling in a rope at a rate of 2 feet per second. All right, so notice that if I call this r for rope, by the way, if I call this r, then the speed at which the rope is being retrieved, if you will, I'm going to call that the r dt. But notice that this distance right here is decreasing. Now, if a rate is decreasing, then the number has to be a negative 2 feet per second. So as you see, it really doesn't matter how you draw the triangle. It really doesn't. What matters is that if this distance right here is getting shorter, then you're going to name that rate, you're going to make that rate negative, all right? Now, if this rate would have been getting longer, then that would have been positive, okay? So it doesn't really matter how you draw the triangle at this point. All right, also what you know is that I want to know when this distance is at 22, all right, when that distance is at 22, I want to know what the speed of this is, okay? So now, after you figure that out, and maybe you can figure this out later, it's really up to you. When you get to here, if you have this picture, you should be able to have that. Take the derivative of this, right? The derivative of 20 squared is a constant, so therefore that's a 0. The derivative, and I'm going to do this again, maybe necessary for some of you. I'm going to take the derivative with respect to time. All right, so that's not going to change. The derivative of x squared with respect to time will be 2x dx dt. And this would be 2r dr dt. Right, now as you look at this problem, all right, you have to figure out, do I have all the information that I need to solve for dx dt? I have r, it's right here. I have dr dt is right there, but what I don't have is x. I don't have x. All right, so at that point, you can go back here, and you need to figure out this distance right here when r was 22. All right, so when r was 22, I want to figure out that distance. So I would have 20 squared plus x squared is equal to 22 squared. And then at that point, I would just solve for that. It's 484. And then I would have x squared is equal to 84. I'm going to break that down a little further. Now, one thing that I must point out is that notice that I took a square root right here. So math would normally put a plus or minus here when I take a square root. However, this distance right here cannot be negative, all right? So because that distance cannot be negative, I'm only going to keep the positive square root. So I'm going to plug this in now. Now I have all the information that I need. I'm going to plug that in right there, okay? So, let's see. That'll be 2 times the square root of 21 dx dt is equal to 2 times 22 times negative 2. So at that point, I'm just plugging everything in and solving for it. Okay, so now notice that when I multiply that, I'm going to divide both sides by all of this. All right, so dx dt is equal to negative 88 over 4 times the square root of 21, which is the same thing as this, which if you get a calculator is the same thing as this. Now notice that the distance of the boat, the speed at which the boat is moving, all right, it's a negative. Now, just to clarify, it's not negative because of the direction that it's moving, but it's negative because this distance right here is getting shorter. As the boat gets closer and closer, that rate is going to be negative because the rate is decreasing. So if the rate is decreasing, that's going to make that negative, okay? So if you have any questions, let me know tomorrow, but the main thing that I want to remember is that if the rate is decreasing, then that rate is going to be negative. If the rate is increasing, then that's going to make that a positive rate, okay? If you got any questions, let me know tomorrow.